Assalamualaikum Madam. This is Group 2 presentation. A statistical technique for investigating and modeling the relationship between variables is called regression analysis. In simple regression, there is one independent variable x and one dependent variable y. Value of y can be predicted for a given value of x, and one of the most basic regression analysis is simple linear regression. We may estimate the unknown parameters beta 0 and beta 1 from the simple linear regression model by using the least square method in order to obtain the best fitting line for a set of data. The least square method is the minimization procedure for estimating the parameters.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hamzazim bin Azam. I will explain about our fila table. First is fact. Fact that we get in experiment is car move more fast with height of ramp. Car move longer if from inclined ramp. Car from low height ramp cannot move far. Over height ramp make car lost control. Next, ideas. The ideas we get to solve the problem is first, set some different height of ramp. Try to put the car on the top of each ramp and repeat as many as 3 times. Third, find mean to get the right value. Next, we use y equal to mx plus b to get regression line, and ssxy over square root ssxx multiply ssyyy to get correlation coefficient. Next is learning issues. Learning issues is a problem that we need to solve. What relation between height of ramp and distance traveled by toy car? Second, what the best height of ramp to put car without cause accident? Third, is all try with same height of ramp make the same distance traveled by toy car? Last, action plan reduce needed. First, statistic module. Second, internet article. And last, additional mathematics book.
Okay, now we are going to show the solution of this table, and the data table is show like this. Okay, here is the data of table. Okay, this is height of ramp versus distance table by toy car. Okay, this try 1, try 2 and try 3 as shown as the video. Okay, this is the height, the value of height, and this mean we get from the total of try 1 plus try 2 and plus try 3 divide to 3, because this is 3 trial. Okay, so this is for each height. Okay, for each height, so it's mean for 3 cm. Okay, so try 1 3 cm, total to try 1 try to 3 cm and total 3 cm. So all of this value is divide to 3 trial. So we get the mean for this height. Okay, so for the next height is the same thing, just total of these 3 value and then divide to 3. So gets the mean. Question 1 dia it asks to draw a scatter diagram. Okay, so for the scatter diagram, okay, this is the diagram and it show the value of the height of ramp versus mean. Okay, so this is the graph, the plot graph of each height. So this is for 3, for 6, for 9, for 12, for 15 and for 18. Okay. Okay, after that and let's see the question number 2. Okay, question number 2. It asks, does the scatter diagram exhibit a linear relationship between two variables? Then he asks to write an interpretation of that diagram. Okay, let's see the answer. Okay, the answer is the scatter diagram show exhibit linear shape from 3 cm to 12 cm, where this is 3 cm. It rise steadily until 12 cm. Then they rise. Then since 12 cm to 18 cm, they drop slightly and like this 18. Okay, so this is the weakness linear lah. Okay, then let's move to the number 3. Okay, number 3 us to calculate the linear correlation coefficient for the data. Okay, linear correlation coefficient for the data. Okay, so it asks to iterate the given answer after this calculation. Okay, let's move to the answer. Okay, before that I'm sorry for show this answer because the word was error in my phone. Okay, now let's move to this. Okay, this is the question number 3. Okay, first we make a table and list all the x value, y value, x square, xy and also y square. Find all the answer, find all the value of this each this equation. Okay, so this is x square where you know the value must be square to 2. Okay, and sy must be multiple x multiple by y, and y square is the same thing where this is y square. The value of y must be square. Okay, then that the value. Okay, after get all this value, we must be find the sum of value of each data. So this mean for data of x or we call the sum x. The sum x is 53. So total of this value of x and total of the value y, then we get 124.ca. Total the sum of x square is 819. Total of xy 362.15, and the sum of y square is 2703.18. Okay, so this is the data table. Okay, this is the important, the first step for before this step. Okay, then let's go to the this formula. Okay, to find r, we must be have ss sy divide to ss and ssyy. Okay, so we need to find these 3 data. So for the data, first ss sum of x square minus 1 over n, and then multiple by sum of x square. So the data in the table given the table and find the value. Okay, after that, for the SSXY, use the formula. It means sum of xy minus 2 1 over n multiplied by sum x and sum y. So take the data from the table and get the value. It's the same thing for the SSYY data. Sum y square minus 1 over n sum y square. So take the data from the table and then get the value. Okay, after we get the three data, the value of three data here, so we can solve the equation. So from the equation, we have SS and SSYY, also SSXY. So the formula is here. So just take all the value here and put it in the formula, and then we get the value of R. Okay, here the explanation about R are near value 1 is strong linear. When R is near value 0 is weak linear. So from the data, from the value we get 1.3138, so it's near to 1 and it is the strong linear. Okay.
Assalamualaikum and hi, my name is Muhammad Azmi Firdaus. So let's move on to another question. In this question, we use the formula y equals to mx plus b. First, we found the m, which is 0.7434, and then we find b, which is 14.2133. After that, we build a table that consists of 4 columns. In the first column, which is the value of s, the second column, the value of y, the third column, the value of y when y equals to 0.743s plus 14.212, and the fourth column is error. After completing the table, we got the graph like this, and at the x-axis, it is the value of x, which is mean, and the y-axis is height of the ramp, which is the value of y. Question number 5, about the prediction when the height of ramp reach 200 cm, the mean measure distance traveled by the toy car must be under 100 cm. That's all.
Baiklah, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Muhammad Zain and my metric number is AA191505. And for PBL, I'm going to present for discussion and conclusion. Alright, this is the slide. For the discussion, this case study is about simple linear regression. Initially, we have to construct an experiment to investigate the motion of a car toy on a ramp, which is to study the relationship between distance traveled by a car in centimeter and head of ramp in centimeter. By performing the experiment, we are able to figure mean of distance independent variable and the distance traveled identified as y, as it depends on the head of ramp. By using coefficient determination R, we can conclude the relationship between variable y and variable x far from being a linear relationship. It is because the data from experiment shown as the higher head of ramp, the distance increase. However, the data show shown more higher head of rate at certain point shown decreasing in distance is travel. It conclude by value of r is higher than 1, which is 1.138. For the conclusion, by completing the experiment, we can conclude that simple linear regression help us to anticipate the value of dependent value, which is why in this case it was the distance traveled by car depend on the head of car. The regression line help to estimate dependent variable more accurate, and it allows to respond variable of individual with dependent value not included in the data. That's all. Thank you.